This is part 3 of our Simple Keynesian Model multiplier series. So in part 1 we have already discussed how government expenditure works. In part 2 we were discussing the tax multiplier, and at the end of part 2 I was discussing what if the government decides to increase its expenditure and at the same time finance that increased expenditure with an equivalent increase in tax. So this is basically called balanced budget multiplier. So this is what we are going to discuss today. It's a small one. So let's proceed. So before going into the question of balanced budget multiplier, let's explain what is government budget. We have already discussed the role of government, or when we introduced government into this simple Keynesian model, I told you that whenever you introduce government into a model, you have a income side which is government's income. This is T. That T can be treated as net of transfer. Okay, so maybe the government collected this TT as the total tax, but some part of that income is transferred also. So this T is basically net tax. So TR is the transfer, and total tax collection is TT. So this is net tax, and expenditure of the government is G. I mean, if it is exogenously given, as we have already assumed it, so it is G bar basically. Okay, and then budget surplus. So this is government's income and this is government's expenditure. So if you deduct expenditure from your income, that is what is called budget surplus. That is your total income minus your total expenditure. So this is TT minus TR minus G, or in other words you can write it T minus G, your income, net income minus your total expenditure. And as you can see it from here, if your income is greater than your expenditure, then we call it budget surplus. The budget is in surplus. That means your income is higher than your expenditure. This is true for your any budget. Say for example your family budget. If your income is 10,000 rupees and if your expenditure is 8,000 rupees per month, that means you have a surplus of 2,000 rupees per month. In that case, we will have a BS which is positive. That means budget is in surplus. So a positive value of BS means budget is in surplus. But if your income falls short of your government expenditure, so maybe your income is 10,000 rupees, by you are spending, but you are spending 15,000 rupees. That means your expenditure is higher than your income. So that means this BS will be negative, and when BS is negative, that indicates a deficit budget. And when BS is equal to 0, that means when your income is exactly equal to your expenditure, you are earning 10,000 rupees, your expenditure is also 10,000 rupees, that means your budget is in balance. Now the question we are interested in, the question what we were asking is, what happens to real income if the government decides to increase its expenditure and that increased expenditure is actually financed by an increase in tax? So basically we are interested to know, if delta G is equal to delta T, then what will happen to delta Y? Remember, when we were explaining the government expenditure multiplier, we were just interested in this delta G. Okay, we never asked the question from where the government is getting this money. We just assumed that government raised its expenditure by 100 rupees or 100 billion rupees or whatever be the amount, but we never asked from where that money is coming. So basically, when nothing is said, that means we were talking about a deficit budget. We were talking about a deficit financing. It can do so by borrowing from the market. It can do so by printing money. But because we don't have money market in this case, we will explain that in the printing model. So just ignore that point. So basically, when we were talking about delta G, we were not sure, I mean, we were not aware of the fact that how this is financed. But now what we are assuming is that this government expenditure is actually financed by an equivalent increase in tax. So delta G bar is basically equal to delta T bar. Why we are interested in this one? And then we want to know what is happening, what will happen to delta. This is this delta is not looking good. Okay, what will happen to delta Y? This is our question, right? Why we are interested in this one? Because remember, when we are increasing G, this is we are increasing. It will ultimately, because as you know from the multiplier mechanism, it will ultimately increase Y. That we know from the multiplier mechanism. But when at the same time the government decided to increase T to finance your its expenditure, because it has increased its expenditure by say 100 rupees, and then that 100 rupees is collected from additional taxes. And as we know that the tax multiplier is negative, that means if you increase your tax, your income will fall. Remember the negative sign of the multiplier, and that's why in part 2 we were talking about, when we are talking about increase in income, we are talking about tax cut, not increase in tax. The policy was of the expansionary policy was of that of a tax cut. When we increase your tax, it's basically a contractionary policy, because it's basically lowering your income. So when you are actually doing both delta G and delta T, you are doing both, that means that delta G will raise your income, but at the same time delta T will raise will lower your income. So the question is, what is the net effect? One force is trying to increase income, another force is trying to bring down or reduce income. So we want to know what will happen to this net income. That's the question we are asking here. Okay, so we will try to explain this in using our economic intuition, and at the same time we will use mathematical tools also to explain what's going to happen. So that brings us to the third slide. Remember, when we are comparing, remember the I think the part 2, uh, when we were comparing the government expenditure multiplier with tax multiplier. Let's bring them together here, okay? Because what is happening here, we are doing both. We are increasing G and increasing T. So here, if you consider the equilibrium condition, what we are doing, this G is increasing, so that will have an expansionary effect on Y. Y will increase, but at the same time we are raising tax, that will have a contractionary effect on Y, because an increase in tax will have a negative impact on consumption. Increase in tax will reduce your disposable income, that will reduce your consumption, and that will reduce your income. So let's explain what happens when you are doing both. You know this expression from our previous discussions. So firstly, I mean, consider them separately, then we'll do both. So how the Y is going to change with the change in government expenditure? You know that the multiplier mechanism, delta G, first round MPC into delta G, second round MPC square delta G, MPC cube delta G, and so on and so forth. And at the same time, when you change delta T, there is a change in T. So that is basically the negative sign, as you know, is due to the fact that if you raise T, Y will fall. If you reduce T, Y will increase. So there was no direct effect. Remember that slide? So there was no direct effect. So all the effects are actually induced effects. And that started with minus MPC delta T bar, minus MPC square delta T, then minus MPC cube delta T, so on, so on. Now, because we are saying that the government is basically doing both together, so it's actually raised expenditure, at the same time it's actually raised tax, and that means we have already assumed delta G equal to delta T. Now if you substitute delta t by delta g here, you just substitute because they are equal, then it is delta g here, or delta t by delta g, or delta g by delta t, whatever. And if you add them, just add those two forces, two effects, because you are doing both, then all those secondary, induced effects, they are cancelling out, because there is a positive sign MPC delta G. Here you have a negative sign minus MPC delta G. Here MPC square delta G. Here you have minus MPC square delta G. Here you have MPC cube delta G. Here you have minus MPC cube delta G. Then what is the remaining effect? Delta Y is equal to, the only effect that remains is this one. Everything else from here, all the induced effects, they are cancelling out. So your delta Y is exactly equal to, so the net effect is delta Y is equal to delta G. Or if you want to find out the BBM, then just write it this way, delta Y by delta G, this is equal to 1. That means in a simple Keynesian model with given assumptions, BBM is equal to 1. So BBM, balanced budget multiplier, in a simple Keynesian model, given the assumptions, BBM is exactly equal to 1. That means your income will ultimately rise by the amount by which the government raised its expenditure. Okay. So in the previous slide, as I was telling you, that one force is trying to raise income, that is the G force, and another force is basically trying to lower income, that is the T force. But remember, when we compared G force with T force, G multiplier with T multiplier, I told you that G force is slightly stronger than the T force. That's why there are some positive effect still remaining. That is the direct one. The direct one remains. Therefore, your income will change exactly by the change in government expenditure. That's why BBM is exactly equal to 1. We can very simply calculate this, because we know the multipliers already. We have the uh, you know the government expenditure multiple. We have already this value. So the government expenditure multiplier was equal to 1 by 1 minus MPC, and we have already derived also the tax multiplier, that is MPC by 1 minus MPC. Now we are interested in dy by dg when dt bar is exactly equal to dg bar. So that means you add them. You add this with this, and you write dg bar equal to dt bar. So instead of dt bar, you just write dg bar, and if you add them both, then what you are getting, it's basically 1 by 1 minus MPC, and then minus MPC by 1 minus MPC. So that means in the denominator you have 1 minus MPC, and in the numerator also you have 1 minus MPC. So that means 1 minus MPC divided by 1 minus MPC, that cancels out. So BB is equal to 1. Alternatively, you can directly derive it mathematically as well using the equilibrium condition. We are going to do that in the next slide, like this. And you have done that for you have already done that for your government expenditure multiplier and tax multiplier. Just remember the equilibrium condition, then this step that step, and up to this they are exactly the same as it was in case of government expenditure multiplier and tax multiplier. Now what we are doing is, because we are interested in G bar and T bar, so we are putting di bar is equal to 0. We are not interested in this term, and we are putting dt bar is equal to dg bar. So instead of dt bar, we are writing this as dg bar, or you can do the opposite also. I mean, you can put dg bar instead of dg bar, you can write dt bar here also. Then what is happening here is, you take dg bar common, then you will have 1 minus c prime into dy here, 1 minus c prime into di as it was earlier. So this is basically coming down here, and then from here you take out dg bar. So dg bar into 1, here you have 1 minus c prime, so 1 minus c prime dg bar. Then you have dy, this is equal to 1 minus c prime divided by 1 minus c prime, that will cancel out, and then dy by dg, we call it BBM or balanced budget multiplier, the value of that is equal to 1. So using mathematical technique, using the equilibrium condition, you can easily derive the balanced budget multiplier, where the value of which is exactly equal to 1. Now what next? Remember, until now, whatever multiplier we have discussed, always we simplified the tax function. We used tax T bar as T bar, that is tax as lump sum tax. Now we are going to relax this assumption, and we want to see. So what we are going to do is, what if tax is not lump sum tax? That is, instead of T equal to T bar, this was our assumption so far. We assume T as a function of income with T prime greater than 0 less than 1. That means del T del Y is basically positive. Higher in income, you will pay higher amount of tax. And as you can understand, this is a more realistic assumption, because this lump sum tax is not realistic, because that, from reality, that people who earn more, they pay more tax, right? So if this is true, we can capture that in a very simple tax function. That could be, you can have different types of tax function, but we're keeping it simple. So we are basically assuming, instead of T equal to T bar, we are assuming T equal to a function of Y, where T prime is positive. T prime is positive means, if your income increases, your tax liability will also increase. And then, if you remember the equilibrium condition, your disposable income, we define disposable income. If you remember that disposable income, YD was equal to Y minus T. But instead of T equal to T bar, we are now assuming T equal to T as a function of Y. So that's going to change your equilibrium condition, where the consumption function earlier was a function of C equal to a function of Y minus T bar. Now what we are assuming is that the tax function, we are incorporating tax function here. So instead of C as a function of C Y minus T bar, we are now using a consumption function which is equal, which looks like this. C is a function of C Y minus T bar. Now we are interested to know, if we change this, how it is going to affect our multiplier mechanism. Is it going to affect at all? Is it going to affect the multiplier mechanism? So that we are going to discuss in the next class. Basically, what we will do, we have already completed, the discussion on multiplier, different types of multipliers, particularly in this case, in Simple Keynesian model. But we just want to generalize few things right now. So the basic understanding is there. So we know them clearly, but we just want to change functional forms a little bit, and then want to see how it is going to change our understanding of a multiplier, if any. So that we will discuss in the next class. That is part 4, and possibly that is going to be the last one in this series, that is SKM multiplier series.